Okay. Online guys, you are also able to listen me, right? Yeah. Yeah. So in the first cell, what we have done using random rand function, we generate random number within a row of 30. Okay. So we can see using head function. This is the preview of first 5 rows with 4 columns we have generated. You can see first column which we name as v1. It is basically 1 to 30, whatever the range of length, and v2, v3, v4 are completely random. Yeah, this is just for introduction. Coming to this read CSV function I want to introduce. So what this function did, it reads our CSV file, comma separated file. In the earlier in the earlier code version, we see there is a create data frame. Okay. This create data frame, basically it convert our generated data to a data frame, which is visual representation. And yeah, it also save to dot to CSV function used to save our CSV file. Then we proceed to read that saved CSV file. Further, in the CSV file in the data frame, what if we want to drop some columns? In the many cases, there are null values. So to clean the data, we use the drop columns feature. So if we like, we can see the df.drop. This is numpy function, and this 2021, what it is? It is index number. You can see the index number in the left. Yeah, this 0, 1, 2, 3. It's basically start from 0 to 29. Let's print it. You can see after 19 there is direct 22 value. 20 and 21 rows are already dropped. Okay. Coming to the principal component analysis. So what actually this is the technique used for dimensionality reduction to reduce the complexity of the data, and these are its application vectors and eigenvalues and all. So we are applying PCA on this. Let's have, okay. So see the you can see the output number of components 1, 2, 3, 4, and their explain variance ratio. As you see, uh, in the first it is 0.55. In the second iteration it's 0.79. In the third it's 0.97, and in the last it's almost 1. So we will see this case in different scenario. In this, what we have did is we generated 5 columns. First is random. Second, in the second feature, what we did, we multiply first column features by 2. Okay. And in the third, again we use random integers, and the third we use permutation of, okay, permutation of first column, and in the fifth feature we assign the values in the range of 2, like 0 or 1 binary values. So what we want to perform is we want to find the dependency of v5 on the v1, v2, v3, v4 features. Okay. Anyone have any problem? Okay. So yeah, again we save this data frame to new a data.csv. You can see this is saved here. In once we run it, it will save. It's okay. Yeah, you can see. And this is visualization of data file. So coming to the variance ratio, this is a definition what we have done in PCA and variance ratio. So as we see earlier, we generated two features from the V1, right? Other three are randomly generated, but two are generated from V1. They are dependent to V1. So we see when we run principal component analysis from the third iteration itself, you can see from in the first it's 0.75, in the second it's 0.91, and in the from the third iteration it's 0.99, means almost one. So what if we select only three components? Those are essential to determine our data. Basically what we have done, those three features which are important among five, we selected them using PCA. Okay, so this is a PCA visualization. Yeah, you can explore. You can change the data set from this. I prefer MNIST because in the ahead we are working with MNIST dataset. I am applying all the concepts on the same dataset, so you can see. Yeah. So this is, yeah. Okay. Let's back to our code. So coming to the classification, what we did in this case, first we generate the data. Earlier we used to generate 30 up to like 30 values. Okay, so in this we have generated up to 80 using same. V2 is based on twice the V1, third is random, fourth is permutation, and fifth is binary values. So now we are going to apply machine learning model. This is supervised, as Chatterjee sir told us. Decision tree was among the most proficient. So let's see. First of all, before that, what you can see basic concept of machine learning. There is training data, there is testing data. In training data, there are X and matlab, there is input data, and with their levels, data levels, we name as Y. And in the test data, there are no labels. So what we have to do is we have to predict on the test data. So first, what we do, we use training data to train a model. On the trained model, we test the data. Okay, so here we split the data, whatever we have generated in the earlier, into train test. Yeah, and for test size we set zero point 0.1. You can change up to 0 0.2, 0.3, whatever, if you want to increase the test size. But remember that you have the sufficient data to train the model. Otherwise, it will be biased. It won't work well. Yeah. So okay. So I forgot to tell. Yeah. For the features, we use V1, V2, V3, V4, and V5 we used as a label, which is binary. So here we are applying decision tree classifier. Using scikit-learn library, we import the classifier. This first we read our CSV file, then we drop v5 because it's going to our label, not a feature. Then we split our data set into train test with a test size 1. You can change to zero point 0.2. Basically what it does, 20% of test data and 80% of train data. This CLF is equals to decision tree classifier. This is key here. This is the classification model we are going to apply, and clf.fit, which is basically fit our training data. You see X training and Y training. Y training is labels, X training are features. And in the last, it's predict, clf.predict. We are going to predict our test data, which is 10% of the original size. Let's print it. Accuracy, okay, it's 0.75, almost 75% accuracy. What if we change to zero point 0.2? Will it affect the accuracy? No, it's zero. No, it's not. Okay. Yeah, yeah, you can see the accuracy significantly dropped, 0.375. Okay. So yeah, as I told earlier, you have to keep sufficient training data and then test data. So you have to keep balance between them. Similarly, here we have implemented different classifiers. Again, instead of decision tree, here we have applied K near neighbors KNN classifier. So let's see its accuracy around 50% only. Again, let's try with different classifiers. Naive Bayes classifier, 0.625, 62.5%. So yeah, decision tree is among best among all. SVM classifier, zero point 0.5. Okay. So this is last random forest classifier we are going to use. Okay, this is 0.5. Okay, coming to the confusion matrix. So what it is, what it does, whatever the prediction of our test data, so you can see a confusion matrix, 1 2 2 3 2 3, I hope. So these are what, these are true positive, false positive, false negative, true negative. Again, okay, I will explain you in the tomorrow session what exactly it is, since we are running off out of time. This is our lab session. Okay. So I have created an exercise for you guys. I thought we could practice here, but it's okay. So here I want you to use Kaggle dataset. Here I have shown the given the dataset link. So here you can access. This is basically NYSE 100, like New York Stock Exchange stock prices. So what you have to do is predict the next, yeah, predict the closing price on the basis of open, high, low classifier, and also, yeah. So in this data set, there are hundreds of stock CSV files you will find. I told you how to deal, like how to hand with a CSV file. You have to read and all. So this is the basically data. You can use open, high, low as a features. You have to predict the close value of the stock. Okay. Yeah, this is data. So this is sorted with the date from 1962 to 2024, I guess. Yeah. Another example is categorizing whether an email is spam or not. Again, this data set is there. You can download from here, and also you have to sign in with Kaggle. With the Google account, you can sign in. It will be easier for you. And also another way is to yeah, uploading the JSON file here and processing. So this is all. Thank you. हो गया, आज का इतना ही था। आपको बस पता होना चाहिए मशीन लर्निंग क्या है। I hope you will practice with the provided data sets. Oh, there are chats. Right, sir. You are now audible. Okay. Online guys, today's session is over. We will meet again tomorrow, and yeah, tomorrow's session will be more elaborative. Today's we are quite of out of rush. Tomorrow we are going to see classification and clustering. We are going to implement CNN from scratch. So you have to keep some idea for that. Okay. Exit.